Hello, everybody. Hello, hello.
Oh.
Hello.
I'm gonna leave because I don't believe in being recorded. So letting you know. Look at the social distancing going on.
Like your background, Jennifer.
No, thanks.
Is that a window or is that a picture?
That's a picture.
Okay, I was like, wow, that's your window. That's pretty
I
awesome.
wish. Yeah. All right. I think we're going to go ahead and just jump in. So this is going to be relatively informal. I put together a PowerPoint presentation more to use, well, kind of use both ways. Obviously, there's information in there we want to share with folks, but then also I'll probably switch back and forth between like the presentation view and the editing view, and we'll just maybe type some notes into it as we go along. So I'm going to share that. Let's see. This one. All right. Okay. So like I said, definitely trying to do this more as a discussion than just like leading a meeting. So we're going to review some of kind of where the NARP language has evolved to, talk a little bit about kind of modeling and directions that we may want to try to go in. Talk about what some of the stuff DRSCW has really been kind of leading on in the whole NARP sort of end of things, but looking at the IPS model. And for those of you that haven't really seen a whole lot about how that model works, we're going to kind of go over it and then talk about how taking that model for tributaries and what it would look like potentially for large rivers, and then looking at the non-point source reduction activities. So kind of all these different pieces that may be pulled into kind of the NARP, and then how the bioassessment program sort of fits into all of that. Please feel free to ask any questions as we're going along.
Jennifer, can we do introductions? Because I don't.
Oh yeah, sorry.
Sorry. Can we go back to maybe the main screen view?
Yeah.
Sorry,
No, thank you. So it looks like I have 15 participants. Oh, sorry. Didn't have everybody. A few other people coming in. Sorry, I wasn't doing my hosting duties very well, and I didn't
have everybody in the waiting room.
No, I had a few people who were still in the, yeah, because people kept coming in and it was flashing at me. So I think we got everybody now. All right, Jen. Cool. Sorry about that. All right. What's the best way to do?
I mean, you can even just do it since everyone's
yeah.
pictures are going to be, if you can just sort of go through your screen.
So I got Dana Ludwig at the top.
Hi, good afternoon, everyone.
And Allison.
Can people say who they're with too? Because I don't know a lot of people on the call.
Sure. So Dana, you want to go? Who do you represent?
I'm with Robinson Engineering, and I work with a few different communities within different watershed groups.
Okay. Hi, my name's Allison Swisher. I'm the Watershed president, and I'm the utilities director for the city of Joliet.
Tim?
Hey, Tim Jaskowitz with Strand Associates.
And we got a couple guys from Shanahan, Jeff, and who else you got there, Jeff?
Dan Drummond, he's the wastewater operator. Village of Shanahan.
Keith McKean, Village of New Lenox, and Lower Des Plaines Watershed Group.
All right.
Jennifer Wasick, I'm with MWRD and the Watershed Group.
Steve? Got Steve Zahner. Yep.
Yeah, this is Steve Zahner. I'm with Robinson Engineering also.
And Rich Gallus.
Yeah, Rich Gallus with Baxter and Woodman.
And who are you
Dan Bounds
representing?
with Dan Bounds with
Village
Baxter.
Bellwood.
Dan Bounds.
This is Rishabh Mahajan from Geosyntech Consultants. I've been working with several watershed groups on NARP, most recently with the Upper Des Plaines group, with the Fox River Study group, and now with MWRD on their HARP plan.
Okay. And then I think Dan Poloquin, you're down?
Yep. Dan Poloquin, Village of Mokina.
Did I get everybody? I think that was everybody.
And I'm Dina Duhalik, and I work at the Conservation Foundation and am now working technical staff with you guys, as well as with the Lower DuPage and the DRSCW.
Okay, so I'm going to go back to sharing my screen. Okay. There we go. All right, so I kind of took some different presentations that we've done, be it for Lower Des Plaines stuff or Lower DuPage stuff or NARP meetings, and kind of pulled some different things together, stuff that Dina, like these next several slides, Dina had pulled together for another presentation, and we have some slides from Stephen McCracken as well. So we're going to kind of go through this. I'm going to turn it over to Dina to go through kind of where the NARP language is at this point.
So, I mean, you guys all have the NARP language in your permit, and so we won't read through all this. There's a lot of text here, but kind of the highlights that come out of this and the discussions that have come, because with each new permit that gets issued by the EPA, sometimes the language does get tweaked and changed, and we're learning more clarification on what the IEPA is thinking about when they write this NARP and what some of these words mean, because some of them are just sort of ambiguous or very broad in sort of what they're really looking at. So they are encouraging that the NARP does need to be supported by data and sound scientific rationale. It is focused mainly on the phosphorus-related impairments, which they all, but since we do not have a phosphorus standard, that sort of does look at the DO, algae, nuisance algae, the aquatic plant growth, some of those aesthetic uses that are, I was like, what is the word I'm looking for? Aesthetic uses that are out there, and things like that, but it is looking at the phosphorus related impairments. And one of the things that has sort of come out that wasn't really clear in some of the earlier NARP language was, what is the end goal of the NARP? And the EPA is really stressing that the end goal of the NARP is going to be a target limit, or what we kind of sort of consider a phosphorus standard, like a number that would be used to write permits for a phosphorus effluent treatment limit as the end goal of these NARPs. You want to go to the next slide, Jennifer?
All right, why is it not?
If you clicked on anything else, you got to click back on the main presentation.
Yeah, I got it now.
I learned that the hard way. And they do give provisions that if you don't think you are impaired or a risk of impairment, you can collect data or use their data to argue out of that to show that you don't need to do the NARP. They give some little things like that. I think we're sort of past that. We know that we have impairments and that we're going to have to address them. So how do we best use this tool that they've given us through this NARP? And the good thing about the NARP is that we are in control of it. We get to write our own schedule. So even if we do come up with a phosphorus target, it doesn't mean that phosphorus target is going to be written into our permits tomorrow. We get some time to prioritize what we want to work on through our NARP process. Because while the target is one of the outcomes of the NARP, they leave it very open for other types of things, such as projects like stream restoration or dam removal or non-point source reductions if you want it to do like a rain barrel program. I don't know if that'd be something that you'd want to do, but they give these options that if you identify what is causing the phosphorus in the stream, what those impairments are, and how you would go about removing them. So we are in charge of our own schedule and our own process. And this is why it's sort of an empowering tool that we have instead of being told what to do. If we take our own data, our own investment, and we get to create this plan to keep moving forward through this. It does have some mentions of things, like I said, like non-point source and point source, but in there, but we're in control of that outcome. I guess that's the main kind of gist of the NARP slides. The EPA has done a lot of different questions on we've done several. Dan Bounds was, and the IWEA Watershed Committee has a sort of a NARP committee. We've been doing these workshops. A lot of you guys have been to those workshops. We asked them a lot of questions and are getting some of these impairments. Like this provision H is always interesting. We don't understand how it will kind of be implemented, because the question comes down to what happens if you have a permittee who's within the lower Des Plaines watershed boundary, but is not participating in your NARP and in your group, and they sort of do their own, and their own is a one-page memo that they wrote with a consultant. I mean, how does that all work? And supposedly that these things will be sort of public reviewed, public noticed with your permit. So other people will have comments on them, and they will judge the NARPs side by side to write those future permits. So things that we are putting in our NARP may be put on folks that are not members of the group. They don't have a lot of clarification on that. But that's something that we're always asking and looking for more guidance on. How do you deal with folks who are within your watershed that are not playing in the NARP developments? I think you guys have we have a couple permittees within our group that we're not sure if they're going to be members or not.
Correct. All right.
And as of right now, this is a POTW issue, but the IEPA does see that NARP recommendations, when they look at the non-point source and other effluent type limits, may find their way into both industrial and MS4 permits down the line. There's not like a schedule for that, but they do see this as being implemented and bringing through all of their permitting programs at some point in the, I'm going to say, far off future. So it's important that we engage not just the POTWs, but the MS4 communities, as well as the industrial users that are members of the group in the development of this process.
Okay. So that kind of gets through where all the language is right now.
Mm-hmm.
I put together a couple of slides just to give people an idea of where we have impairments identified from the 2018 303D list. So this is the upper part of the watershed, and I just highlighted either the DO, listed for DO or listed for phosphorus, and then we have some segments that are listed for both. So I think this shows up, so we can see like up here in segment G30, it's listed for both, versus up on Higgins Creek, it's only listed for phosphorus. And then our next, and in the bottom part of the watershed, in our tributary areas. This is kind of what would be the focus area, particularly for the DO and phosphorus impairments. All right. So a lot of the kind of thoughts in the beginning are, what type of modeling would we be looking at doing for the lower Des Plaines? The NARP language itself, as well as Illinois EPA staff, do not have any specific recommendations for models or requirements for a model to be used. So Dina, if you want to talk a little bit about how DRSCW has approached the modeling, and it's different than kind of where things are laid out now.
Yeah, so the IEPA has said, been very clear, they're just looking for that scientifically defensible and gets to those objectives of reducing phosphorus and those phosphorus related impairments in the streams. So the DRSEW sort of has two efforts that are ongoing, and really, if we had the choice, we would really just have one. And so that is the IPS model, the Identification and Prioritization System tool model. It's been called all sorts of things, but we're going to talk a lot about that. But that is our stressor response model. That is where we have taken all the biological and physical and chemical data that we've put in there, and we've tried to do what the NSAC committee did by looking at where is that break point in those bugs and fish that go from that meeting that general use standard to not meeting that general use standard. What are those combinations of stressors, and where do those break points happen? Like when you look at all the data, and what are those prioritization of those stressors? Because, you know, we have hundreds of stressors, right? We have everything from the nutrients to demand parameters. We have chloride, we have metals, we have PCBs, we have all sorts of things that we're monitoring during our bioassessment. So the IPS tool takes all that data, and we'll get into that in the next slides, and then develops not only benchmarks, which would be like standards or thresholds, but where we start seeing the movement from the fish communities and or the bug community meeting that general use standard and set sort of levels. And then it also prioritizes those stressors by watershed, segment, and reach. So you can actually look at a specific site and find out what are the specific stressors there, and they may be different from someplace else. And we'll have examples of that through that presentation. So that's really where the DRSCW is focusing most of their NARP work, is they're going to use that model to sort of come up with that phosphorus threshold. We have it, we'll talk about it in a little bit. And then use that to help us select what stressors we work on, what projects we work on, and set that outline. Now, sort of in the background, we do have a second modeling effort going on that's a legacy model for the group, and that is some DO, dissolved oxygen, TMDL models. So in 2004, why the DRCW was started was that the EPA released DO TMDLs for the East Branch and Salt Creek. Based on very limited data, that was what sparked the DRSCW for being formed. Some plants on those streams were not happy with the amount of data that was used, and went to the IEPA and said, if we found local money, could we redo these models without getting these really strict BOD and ammonia limits that were based on, you know, like 5 data points? And the EPA said yes, and that's what started the DRSCW. So we have these old legacy they're Qual 2 EK. They're an old qual model that's hanging out there. And as part of our special condition that we're undergoing right now, we sort of threw it in that we would go ahead and update them, because we've been collecting DO data on those streams since they were finished in 2008. So we have, you know, 11 years worth of data that we would recalibrate and revalidate them. And so in addition to those models on Salt Creek and East Branch, we're going to go ahead and develop one for the West Branch and the Lower DuPage. That's sort of that more traditional loading model that you think of when you think about water quality standards developments that you're seeing across the nation being sort of used in some of these processes. And I don't know, you know, Jen, or, you know, that like the Fox River Study Group is using a qual-based model. I don't know what modeling they have planned for the cause, if they've done that yet, or with the upper Des Plaines, but those are sort of those traditional loading models, like how much can we put in before that impairment happens? And if the DRSCW did not have those requirements in our special condition to update, we probably would not be re-updating those models. We would have been focusing solely on moving forward with the IPS as our basis for our NARP.
And some of the kind of other benefits is that we're already looking at using the IPS tool as we're moving into tributaries this year. So we're doing Hickory Creek this year, and then the rest of the tributaries next year. And as part of the reporting that will be a part of that bioassessment for this summer, it will run through the IPS tool. We will get these outputs already as part of the work that we're already doing. The challenge with the IPS tool right now is that it was developed for and based on data from tributary streams. So there's pieces of it that we would need to kind of rerun on the stressor analysis, stressor ID part of it, that would need to be rerun for large rivers and using large river data. But we'll talk a little bit more about that later. So part of this discussion, as Dina and I have been talking about this and kind of looking at trying to figure out what we want to do for modeling, what would be the best approach. Kind of her question to me was, well, why wouldn't you just go all in with the IPS? We're ready, you know, we're collecting this data. You know, we have benchmarks, and DRCW had actually hired a consultant to do essentially like a peer review on the whole process, all the statistical packages that were used to come up with these numbers. And that has come back that there is a lot of confidence in how that data, or how the model was put together, and all of the statistics that were used to come up with those numbers. So as far as DRCW is concerned, it's a defensible, they feel very comfortable from defending the numbers that they've come up with out of it. So I'm gonna go through a bunch of slides. Yeah, question, go ahead.
Yeah, so maybe you'll cover this in the next slides, but if I understand, so the response in the IPS tool is really the aquatic, like the habitat and the aquatic life. We're looking at how the fish and the macroinvertebrates would respond to the changing in loading. For the NARP purposes, it's looking at what projects would address DO and uses algae. So is the IPS tool also geared towards looking at, like, how would the projects look at improving DO and nuisance algae?
Well, so there's, I guess, a couple pieces there. One, well, particularly with the DO, and Dina chime in, but our endpoint is good fish and bugs in the stream. And so if we can, meet the aquatic life use goals for the stream, whether or not there's, you know, I mean, that's where our goal is. It isn't necessarily to meet particular numbers. And as we are able to address projects and address those, like, I mean, that's been the challenge with phosphorus, is we have phosphorus issues where we don't have treatment plants, and we have places where we have potentially higher phosphorus levels, but still really good fish and bugs. And so kind of pulling those things together and really having our target, our endpoint of meeting fish and bug scores in the stream.
But the IPS tool gives you both. And it gives you both because it does come up with a threshold. It does come up with a number that would give you, solely independent of other things, what would have the bugs and the fish meet that general use standard. So it is giving you a target, just like water quality. That's the goal of the water quality standard. The goal of a water quality standard is to be protective of fishable, swimmable. So swimmable is a whole nother discussion because we're not looking at those biological hazards, but making those waters fishable. So whether those macroinvertebrates or those fish meet those objectives. So we are looking at those independent uses, and it does prioritize where you are with those uses. Because what sense is there, sort of in the DRSCW argument, is what sense of there is it to go to very, very low phosphorus levels when phosphorus is not a priority stressor in the streams? So even if we invest, you know, for our watershed plants, it's like $250 to $300 million of infrastructure upgrades. That's not going to change the actual water quality in the stream because phosphorus is not a priority stressor. There are other things in front of it. So let us work on some of those other things, and we will get to that. When phosphorus becomes that priority stressor, then we will work on that. And the NARP process gives us that flexibility to be able to look. I mean, our NARP language, which is slightly different than yours, gives us the flexibility to do that. And we've been working with the IEPA and the EAGs on this method, and they are all very acceptable in saying that this is a way that you can go about your NARP development. So it has been accepted by the two main reviewers of the permit.
Have the EAGs brought up recreational uses or aesthetic issues at all?
Not so far with us. I mean, I think we're slightly different. Most of our plants, because we do have fecal coliform TMDLs, we do have the fecal standard at our plants. And so we're still, we're working on that through the TMDL implementation. And then we have a couple aesthetic uses, but not a lot.
I was just thinking for recreation, maybe it's not as much a deal on the smaller waterways, but people have said that algae can cause, or plants can cause, an aesthetic condition that doesn't allow for recreation.
Yeah, we have not had that on our streams. I mean, I think we're very different than more of you guys, where you guys have more sort of lake conditions where you have that. We have a little bit of that on the lower DuPage system. But up in the upper DuPage and on Salt Creek, I think the water is, we're moving too fast to have a lot of those issues. I mean, we don't have a lot of significant on our streams, which is very different than the Fox River. And I don't know a lot about the displays. I'm still getting caught up on that. We don't have a lot of algae issues. Those, like a lot of those visual aesthetic impairments that you think of when you think of that.
Okay, thanks.
But isn't ultimately the goal of the NARP is to get rid of these impairments, is to move towards that? Like if there's a DO impairment, you need to have a plan to get rid of those impairments.
But as you know, there are many reasons besides for phosphorus and nutrients that cause DO impairment.
Sure. Yeah,
so
yep.
That's what this is allowing us to look at, some of those other issues. When you look at our streams, example, Salt Creek, if you look at the Qual 2 model for Salt Creek, there's two big, huge DO sinks, right? Neither one of them are associated with nutrients. They're associated with physical structures. So this tool sort of gives you that, both of those.
All right. So I'm going to go through and, oh, sorry, was there another question? Okay. Sorry. Okay. I'm going to go through a number of slides that that Stephen had put together. So I'm going to do my best at getting through these. So kind of what is the idea behind the IPS model? And so it was a way for us to really take all of the data that has been collected, as well as other landscape data that we've been able to pull through GIS from across the region, and put that information together to identify what the kind of most important stressors are to aquatic life. Because again, our end point is meeting that aquatic life use goal. So looking at what the designated uses are for the streams, looking at which reaches are impaired, and then standardizing kind of the approach to looking at all of the data together and to figure out how we can meet that aquatic life use. So we look at things both at the site level, the reach level, and the watershed level. And with the newer kind of update, because DRCW developed this model back in 2011, and then over the last 2 years, they've been working on really updating it and looking at a much bigger pool of data. And so originally, pretty much everything they were looking at from how do we restore and get to meeting our life use goals. So, you know, working on impaired waters, but as we pulled in a bigger pool of data, and this was the point of getting that wider range of poor to excellent sites, there is also a portion of it on this go around where you can also look at susceptibility and threat. So looking at waters that are attaining. Use the right button here. So really looking at what is the likelihood that we can actually intervene with projects to restore key factors and really be able to meet those aquatic life use goals. And then also to quantify through that restorability, how do we use our resources in the most cost efficient way? And what's the likelihood and level of confidence that we have that if we put funds into a particular project that we're going to meet the goals of restoring those aquatic assemblages and meet our aquatic life use goals. So there's a lot of data that's involved in this. Much of this ambient data is what we collect through the bioassessment program. So fish and bugs, water chemistry, sediment chemistry, habitat data, so it's the QHEI. And within the habitat data, there's, I think, 12 different metric areas of information. So looking at bed condition, at sinuosity, what's going on the bank. So there's a whole number of pieces of data that come in from the habitat. and then that land use, what's going on in the watershed, road density, land use, impervious surface. So there's a whole number of pieces of data that all come in together on this. And then, as Dina said, there's a whole list of stressors, this data that we collect. And so looking at how to identify what the benchmarks are for those stressors, and then how to rank those stressors as we go along. And so wherever there was water quality criteria, standards available, those standards were used. And then based on the data that, the broader pool of data, looking at kind of a regional derived benchmarks. And then we also used reference sites and looking at those reference conditions to compare to. So the dark green in the middle there are the DRCW sites, and that's what the original IPS tool was based off of. The latest go around, they pulled data from Upper Des Plaines, from Lower DuPage, and then a whole bunch of IEPA data that was used. And there were, go ahead, Gina.
Yeah, this is all paired data. So this is all data where there was fish, bugs, habitat, and all the chemistry parameters. So that's why like the Fox River Study Group's ambient water quality program data is not used, is because it's not paired with the bugs and the fish and the habitat. We need that full picture of data.
So here's a shortened list of a number of the stressors that were looked at. I think they started out with a list of about 200 and kind of pared it down as they went through different ranking systems. And then they looked at things individually as well as in groups, or baskets as Stephen liked to call them. But this is kind of how a number of these different stressors were grouped together in different categories. Oops, oh, I thought I took these animations out. Sorry.
They love these animations.
Yeah, get all of these up. Oops, and I went too far. So I just wanted to kind of show some of the examples of how data was looked at. So looking at that top graph on the right, you can look at as the number, as your IBI goes up, the number of sensitive fish species that you have, and these are sensitive to habitat in particular, that number goes up. And so then you can look at the sensitive QHEI sensitive species, habitat sensitive species, compared to the QHEI. And obviously as your QHEI goes up, the number of sensitive species goes up. And so there's a really nice relationship between the QHEI sensitive species and IBI, as well as then those species back to the QHEI. And then you can see as you look at what those numbers are, and the different aquatic life use categories that are in the table come from Ohio. So they use warm water habitat, excellent warm water habitat, warm water habitat, modified warm water habitat, and then just very poor. So rather than just having a straight aquatic life use, like we just have general use. But this is a way to kind of break those things down, and then you can use that information to create a stressor ranking.
Yes,
on the bottom.
I think it should be clear here that how these stressor rankings were done, because we'll get into some numeric values in the next couple slides, is that they are sensitive species indexed by the most sensitive group. So what they did is they took the top 10 most sensitive species of fish and the top 10 most sensitive species of macroinvertebrates and calculated these, and then what we are looking at are the most sensitive. So sometimes fish are the most sensitive to that item, and other times bugs are the most sensitive to this item. So QHEI has more impact, is more, the limiter on the QHEI is the fish, so that's why we're looking at the fish data. These are not over whole IBIs like you are based on for your 303D listing or those numbers that you're used to. We are looking at a subset, the most 10 habitat sensitive fish in this case. And so these are pretty tight groups, you know, these are pretty conservative values.
And then just to kind of give a different look, because conductivity just it works a little differently, obviously, than the habitat scores. But again, taking the most sensitive fish species to conductivity and comparing that to the overall IBI, and then looking at how those sensitive species drop off as conductivity goes up. And conductivity is closely tied to dissolved solids in the water, and in our case, chlorides definitely. There's a very strong connection between chlorides and conductivity. And then, so as each of these have a ranking score, and then we're able to apply those to the different sites, we're able to come up with either a restorability score. So if a stream is not meeting its general use standard, and it falls into that fair, poor, very poor area, we're able to put a restorability score on it. And if there's sites are meeting, then we can either look at susceptibility to it going below and no longer meeting, or on that threat. So if it's a high quality site, what the level of threat is to that site. So that is the difference. One of the differences in this round of the IPS model is that we are looking at both the restorability side and then the side for those sites that are meeting. And so looking at how they look at those numbers and come up with what those scores are, we can look at the IBI scores. And so the colored dots are the different ranges of IBI score. So the darker red is an IBI score of between 0 and 15, and then it goes up in chunks, 15 and then 10, groups of 10. And so you look at the thresholds at the 75th percentile and kind of go up the line for the very the excellent level of IBI, so the 50 to 60 score. You know, that number of chlorides is somewhere around 40, and to meet at good, the benchmark is about 120. And again, this was for fish. Actually, this one doesn't say. Was this fish, Dina? Do you remember?
I think chlorides are
Yeah.
good. And so I think this method that is being used to develop these thresholds or benchmarks, we sort of use the words interchangeably throughout our discussion, is that this is the process that NSAC set out originally with trying to do for statewide data and then EPA ecoregion data, looking for where there is a break point. I'm like pointing at a screen and no one can see me, but where they were looking for where there was a break point between meeting a standard and not meeting a standard to develop a standard. This is sort of traditional standards development, this stressor response model. And so in addition to chloride, we've done all of those other pollutants. I think Jennifer's got phosphorus in next or somewhere in the presentation.
I don't have the plot for phosphorus. I didn't have that in Stephen's presentation.
Okay. Yeah, we were slow to sort of release that because obviously everyone was looking for a phosphorus number since the NSAC folks couldn't come up with one. And then they used a different means, and that's what was published in that report with that 0.1, the other means of evidence. So we were able to find a break point, find a statistically significant value through our method. So this is not anything new. This is something that we invented and math that we made up. This is normal use of a bunch of different types of algorithms and statistical analysis tools to come up with these standards. And because of the regional data that we were working with, we did find a ratio, a fairly good ratio that came up with a phosphorus benchmark. And we have these same plots for the majority of the pollutants that we monitored for. So you can see that chloride, the 500 milligram per liter that we have is obviously, based on our analysis, is not protective enough for water quality in our region. It should be somewhere closer to that 120.
All right, let's see. So after taking and going through each of those, each of the different stressors that we were looking at and coming up with the benchmarks, there was a way that they weighted each of the stressor values and looked at it again, like Dina said, taking kind of the upper percentile of fish species, so the most sensitive fish species, most sensitive bug species, and then went down through, plotted out the thresholds for each of them. And then as it kind of follows around, derive the biocriteria-based stressor endpoints. And then once they looked at it for both fish and bugs, decided which one was the most sensitive, and whether it was fish or bugs, then that went up sort of to the next level. And then looking at what then developing those numbers by category. So the excellent, the general use. So that was kind of the table on that last slide. And then there was a rank, and then they looked at all those and ranked them. And so that's the next table actually. So it shows that fit score. The lower the fit score, the more important that stressor is to aquatic life. And so we were able to, this isn't all of them, but I think they kind of got to a point where these were this is for most of the stuff that we sample chemistry, habitat for, but came down to a list of things that were that we see most often in our data. And Dina, like with the point, like as you have the same numbers in the fit score, we don't necessarily have a way to deter, like all the ones that are 0.04.
Yeah, so think of that as like an R squared is like, it's sort of, if you're looking at like thinking about it in traditional like graphing and fit ratio, in like ratio of how well the data fits. What these are showing it, this is where we feel like we have a fairly good relationship between aquatic life and that stressor, and whether an aquatic life being either those bugs and their fish, that data makes sense, and we do have that sort of break point of where it falls off, where we could say that would be where you would set your standard. Something, so when we first did the DRCW did that, phosphorus was like 14. Like it wasn't as clear, it was a lot space, it was not a priority. It did not have a good fit, and it did not have a good prioritization on this scale. It was pretty low in our list. And then you can see here, it's moved up to being one of those top few ones. So then this is showing that phosphorus is an issue in our watershed. And then it's like, how do we want to address that moving forward? And that's what we're trying to figure out now.
And then, so this is kind of how these numbers play out for some of the different, so these are the benchmarks, and I put the red arrows on the side because MBI compared the benchmarks that came out of the IPS tool with some of the other benchmarks that are used in Ohio, and I think they got a couple from Minnesota in here as well. So you can see that we fit pretty closely, where there is something to compare to, we fit very well with numbers that others have come up with. And so the green column is really our key column, because in Illinois, that would compare to the general use column, which is where, what we target. And then all of the IPS data it's all in an Access database that is then brought into Power BI. And this is something that we will have out on the website. Well, DRCW will probably be the first one to have it out on their website, but it'll have a really nice interface with the data. So Power BI just gives you a whole lot of tools and power to be able to graphically show your data. And so these kind of outputs, I guess, outputs of the model in a visual way will be a really nice way to be able to share data with other folks. And I thought I had these switched, that's why I'm sorry about that. I didn't move this one up. So this is the threshold that the IPS tool has pulled out for phosphorus. And so it's that top line. Again, you can see how it compares to numbers from other states, Ohio in particular, Minnesota, as well as the NSAC report. And so the 0.28 milligrams per liter phosphorus would be an in-stream target to meet the general use standard. I don't know if you want to say anything more about that, Dina.
No, I mean, that's
Just-
what we're working with right now, and we're trying to figure out exactly what 0.28 in-stream target means. Could it, for an effluent standard, could it be higher? Thinking that there could be some potential dilution in the stream, like how does that look? But this is sort of the number that the DRSCW is very acceptance of. We've talked with a large number of our plants, and they feel like this is a goal that they could potentially meet in the future. And, you know, it's sort of looking at with our upstream permit negotiations and through our NARP that we may set a target based on this 0.28 for an effluent limit at some point in the future, setting that long-term goal. We've discussed 2045, we discussed 2040. You know, we're still in those discussions with both the EAGs and the IEPA on what that would look like in a permit, but we are very confident, like Jennifer mentioned, we did have a lot of peer review and a lot of other analysis done on this. And we feel like this would be our watershed target that the NARP is going to recommend.
Mm-hmm. And because the state, sorry, go ahead. What was the question?
So is this 0.28 number is based on all the data that's been collected, that includes the RSCW, the upper displays, and all the data, right?
So it's sort of like,
or is it just a,
it's sort of like a regional water quality standard. Yes.
okay.
I mean, it's not officially, it's not accepted as a standard, but that would be what it would be looked like. The development process that the IPS method took would be exactly what a state would do as they were developing a water quality standard. Ours is regionally based. It cannot be just based on DRSCW data because we don't have that. I mean, we don't have that high-end quality sites. In order to really get a really good number, you need to have excellent sites and poor sites, right? We tend to have in our watershed a couple fairs, one or two goods, and lots of really bad. So our original model, we couldn't find a relationship or even be able to get this number from the original data because it was too skewed in one direction. But by bringing it out and bringing it into some of those cleaner basins like Big Rock Creek and some of those reference sites in Joliet, Aux Sable and things like that, we were able to get some of those excellent sites. And you know, what's interesting to see is that our excellent water quality sites are not 0.1. Some of them are 1s, some of them are 2s, but they're meeting their aquatic lives even though they have these higher levels of phosphorus. And so when you look at it like that, that's how that number sort of all, you know, there's a lot of math that's way above my pay grade that goes on here that gets used into bringing it in this 0.28.
Jennifer, I don't know if you're going to talk about this later, but I guess I'm still not sure how this translates to the main branch of the Des Plaines River because
right. So
much.
So that's where we would develop. That's why we have this done in this the same methodology could be used to develop numbers for the main branch of the Des Plaines, but we need other larger river data brought in, and that's why it'll work well for your trips. We can shove, for lack of a better word, shove your trip data in here and spit out your priority stressors. Because some of your data has been used already regionally, has been used to get these benchmarks. These benchmarks won't be rerun at this time. You would just have these, but we would develop a second model with MBI. I mean, if you wanted to go with the IPS, we would work with MBI to develop a big river model. You know, we get data from the Kankakee, from the Cause, I mean, some
Rock River,
the Rock, the Illinois, to help bring in that extra data into your site, into the model to give you enough data to be able to do this. Just like how we had to blow out that map to those counties, your map's just going to be bigger.
And that data exists, we think, or?
So I think the EPA will have some of it because, and we have it because they gave us their, well, we have a lot of it. I think I have the Rock, I have all the Des Plaines. I think I have the Kankakee, but they will share that data with us and then we'll have to look from there. And this is where I think Jennifer had casually mentioned to me in a phone call, well, maybe this is where we work as a watershed group, the team, with some of like, because Karma's doing this on the Kankakee. So if they're going to collect it, is there a joint effort we could do with them to help get some of that data too?
Right. And, you know, and if this is the approach that we go in, if we have to get some other data collected on some of those big rivers to be able to fill in those gaps, maybe that's where funds are going instead of like putting money into like a Qual 2K model.
Yeah.
Because this will get us there. And MBI has has used this whole modeling process on large rivers in Ohio. So they do have confidence that the same structure would work. We would just need to get data from those big rivers.
And is it just the size of the river, or also, because I would say the Kankakee and the Des Plaines are not comparable. I mean, I don't, or is that their only criteria?
No, I think we'd have to look at I mean, we'd want it to be similar in the terms of like, you know, some like weather and things like that, because all those things impact. Like, we're not going to bring in like
Big Muddy River.
Or but there's one river downstate that's really super sandy, like it actually has like, we're not going to bring that data in because that's the only excellent site in the state is actually on that river. So we're not going to bring that river in because it's not comparable in terms of structure. I mean, the Des Plaines is very unique because it's a shipping channel and stuff like that, which I think we would just have to build some of that, work with MBI to build some of that into that model. And then that gets us onto a whole nother discussion, which, you know, is like, is the result of some of this stuff is that we need a TALU system. We need a tiered aquatic life system, sort of what, and you'll see some of this as we get through the results of the DRCW model this year, is like, our priority stressors are something that I can't do anything about.
Right.
And so I can't get there. Like, if my main stressor that's driving my water quality is impervious area, I really can't do a whole lot about that. Green infrastructure is great and all, but it's not going to solve, I can't get enough of it to do what I need it to do, right? So do I need to argue at some point to be held to a different water quality standard than the general use?
We've been throwing a lot of information here in the last few minutes, and I'm not overly immersed in the IPS model. And I just want to make sure I'm absorbing all this right. So we have a bunch of data from a bunch of watersheds where some watersheds are good, some watersheds are bad, based on the rankings. And we've imported all that information into this model. And then we determined the priority list of what is the most impactful to the, you know, what are the stressors to the water quality and aquatic life. And phosphorus was towards the top of that list, because you said the lower the number, the higher the impact, or more significant than the impact. So I got that part, but then, so these values, so you're saying that we looked at all of the data and did all the math, and we're saying based on the watersheds in this area, to have a good watershed, quality water, aquatic life watershed, we need to target a 0.28 phosphorus limit. Is that what I'm?
Yes. So think
Did
of
I summarize that correctly?
Yeah, yes, but kind of think of it as two separate efforts. So there's these benchmarks. We spent a lot of time doing some regression analysis and statistical analysis to look at what are these benchmarks. So we have benchmarks for things that are not priority stressors. You know, we developed all these water quality standards, and then that's a separate effort. But then we also took that same data and put it through different mathematical models to do that ranking. So they're not actually tied, like they're not tied together in a way, but they are. I mean, it's kind of hard to explain. They're sort of like two efforts.
So you're saying the stressor analysis is independent of the numeric analysis on the concentrations?
Yes. Yes. The rankings. Yeah.
And part of another way to kind of look at it is that the 0.28, in order for phosphorus to not be our bottleneck of meeting aquatic life use goals, that in theory it should be below 0.28.
But that doesn't mean that it needs to be 0.28 everywhere, because of some of these other there's a lot of nuances to this. It doesn't mean that the 0.28 needs to apply everywhere as a blanket statement. And it doesn't mean that it's the first thing that we should do in every watershed. Or every.
Well, it shouldn't be the limit for every treatment plant, because every treatment plant is going to have a different impact onto the stream.
There could be potential for that. That is true. And that's where we're still working out what that means.
So
right, that might be one concern that I'm thinking about is if we put all the data from the different watersheds together, we're sort of losing the uniqueness of each watershed, right? So their disciplines might be very different from Rock River and the impact of wastewater treatment plants and how they operate. And I think one of the concerns that was with the NSAC was they tried to come up with a regional standard versus looking at it from a watershed specific basis. And I know there isn't enough data on watershed.
They looked at ecoregions, which are different than what we did because we're much smaller than an ecoregion. But one of the recommendations of the NSAC was to look at regional or watershed specific standards, which is what this is.
Right.
So Dina, do you want to go through these two slides? So these are kind of how the tool, so how all this data is then used sort of at the watershed and reach scale.
Okay, so when you're saying all the data, we're talking about the bugs, the fish, the chemistry. We're not talking about benchmarks. We're not, so think about the benchmarks, just set up a bunch of regional water quality standards that are independent. So if there were no issues, other issues, 0.28 of phosphorus should make us meet water quality standards. 120 of chloride should make us meet water quality standards. Pretty much how water quality standards that we currently have in our permits are done now. They're independent. They're done in a lab. They kill things until they die, and then that's how they get a standard. Sort of, kind of. But that's a general use. So, but now what we have is we have all of these stressors, right? And we have all these stressors that we've been monitoring: bugs, fish, habitat, chemistry, land use, things like that. So that gets used and that gets developed into what would be our primary stressors. What is causing impacts to the water quality? What is causing impacts to the bugs and the fish in that stream? Like if you had to pick, if you had to look at us, you had to stand at a site and say, what are my main water quality concerns right here? That's what this portion of the process does. And I probably should have done the other slide first.
I can go there.
That's fine.
Do you want?
So actually, let's look at this map real fast. Sorry, this is the East Branch. And you can see EBO 7 in the center is that's on St. Joseph's Creek. That's a little trib. And then two of the lower sites are labeled. You don't need to know exactly which one they are, but EB 43 is a site, and then EB 39 is further downstream. So I pulled these out mainly because they were sort of easy to read. But if you go to the next slide, Jennifer. It gives you what those this is what the IPS has determined the primary, secondary, and tertiary stressors are. And I sort of picked these three because they have slightly different nuances. It was overwhelmingly in our results that the amount of development and how urban we are is our primary stressor, mainly related to impervious area. It explained like 99.9% of the impairments in the creeks. Okay. We can't really do a whole lot about that, right? But you can see that at the East Branch at Wayland Lake, substrate shows up and TKN shows up as a primary stressor. This is shown, like, this is through the mathematical analysis. These are what is the primary reasons there. So I have a habitat issue, I have a nutrient issue. And then it does secondary and tertiary stressors. And those are all based sort of on how Jennifer was trying to talk about, like those rankings that they have that are going on. So you can see that a lot of them, once again, for us are habitat related, at least on these streams that I picked here. Channel, QHEI, Jennifer's, my little box is over the one, most of the tertiary ones I can't see. But I can't move it. I think that's a Jennifer.
Oh, I don't know if I can move it. So tertiary for EBO 7 is impervious area, 30-meter buffer, total phosphorus, low DO, QHEI, turbidity, sediment, and metals, or sediment metals.
So, I mean, the way that we looked at, I mean, and we didn't kind of go through this, so I think if you've seen any of the IPS presentations before, when we looked at impervious area, we didn't just look at, we looked at impervious area in various factions, and that's what these 50 meters and 30 meters are. We looked at it as a, like if you have a dot, you have a 30-meter radius, a 50-meter, radius, and then all tributary area. And then we looked at those as independent factors, as just like 30-meter tributary, 30-meter or 50-meter tributary, because different pollutants act different. Like a dragonfly doesn't just use the watershed, buffer, right? It uses the longitudinal buffer. So you got to get, even if it's outside that drainage area. But chemistry obviously is a drainage area pollutant. You don't got a lot coming up to a site. So that's why we looked at several of these different factors in these different cutoffs. And this is where those 50 meter and 31s come from. And so like urban, when it says watershed, that's that whole drainage area to that site. So now it's going to do this for every single data point that you have, right? So how do you decide where you do your projects? We don't have money, right, to go out and fix our entire length stream miles of stream. You have to sort of figure out how to rank and prioritize those. That's where you can go back, Jennifer. So we have two different ways, we have two different factors that we look at in doing this. And really, it'll be up to you as a watershed group to determine how you need to do this. It's not like a set methodology. Prioritizing and ranking is really a lot of best professional judgment and a lot of watershed knowledge. Now for the DRSCW, we have decided that to rank restorability. So how likely would it be that we could move that biological endpoint? We could move from fair or poor to that good range. We based it on the 50% of the score is based on the number of stressors. The less number of stressors you have to move, the easier it's going. We figure the easier it's going to be. This is the same methodology that we used in our last IPS that we're actually implementing and measuring and doing projects that we could talk about another time. But 50%, our assumption is, and what we base it on is 50%, the lower the number of the stressors, the higher the restorability. And then we also looked at the deviation from the biological endpoints. So the closer you are to that good, so sites that are fair or high poor are going to be easier for us to move to that good range than a site where the IBI or the MIBI, the FIBI, the MIBI is 2, right? You would think that if you have an FIBI of 20, it's easier to move that to 41 than it is to go from 2 to 41. So we've taken this ratio and developed a score together. It's rated on 1-to-1 kind of ratio based on those to come up with the thing. So the higher the score, the more restorable the site is. So if you look at the top of the legend on that map, you see the little circles that the higher the score, the more restorable it is. So those blue sites down where we were, like EB43, has a fairly, we feel confident that that site is highly restorable based on these things. Limited number of stressors, and it's fairly close to that good endpoint. But then we have to decide, once we lay all those out, you can see we have a lot of greens, which is probably like pretty good shot. Might be worth considering doing a project at those sites. How do we prioritize those sites? And for us, right now, we're prioritizing mainly based on its availability to adjacent land use, because we've seen a lot of these projects and a lot of the stressors that we're seeing are habitat related. Those projects require land because if you want to increase meanders, you want to do stream bank stabilization, you want to improve buffers. If you're doing that through a subdivision, it's a lot harder to do that in a subdivision than it is to do that in a forest preserve or a park district or a vacant lot. So we have ranked our prioritization mainly based on its availability to a 400-foot total buffer. So when you looked at the site and the stream, do they have 400 feet total or 200 feet per side of adjacent land? And that's sort of like, you can see those odd shapes that are sort of behind the dots. Those are the prioritizations based on access to land use, access to open space. You could prioritize in the displays based on a bunch of different, anything that you would want to if you were doing this model. This is how we have chosen. And so the other watershed groups, the lower display, the lower DuPage and the upper displays, DRWW is also using this model, will be able to prioritize based on what they would like to do too. But ours is based on, right now, on open space. And then you get a final ranking by multiplying them together, and then that pops out your priority project list. So that's where you would start first in your NARP on moving forward.
I had a thought I wanted to just throw out there while we're talking about this. So until we have flying cars and we stop spreading road salt, I don't see us being able to ever meet 120 in the winter.
Yeah.
So, which made me think, well, wait a minute, could we apply seasonal or maybe have an annual total, and then maybe seasonally facilities, especially I'm thinking of nutrients and treatment plants, because some treatment plants can perform better at different seasons.
Oh yeah.
And maybe that instead of having a monthly average concentration of 0.28, maybe they have a total annual poundage, and they meet that annual poundage throughout the year, by a varying concentration.
Yeah. And that's some of the things that you can think about with these numbers. These numbers are not, a water quality standard is obviously implement the easiest it can be. They do this research, they get a number, and everyone gets that number, but that doesn't mean that everyone needs that number, right? But the NARP is giving us the power to really customize them and to start thinking about some of those questions that you, like that concept that you just brought up is like, okay, so we need 0.28 is maybe that 0.28 is only critical during certain times of the year. Unfortunately, the times that it would probably be critical during the certain times of the year is probably the hardest time for the plants to meet it. But, to sort of look at that, that's where you would start to think about that. And that is sort of where we are and why the DRCW doesn't want to implement, a 0.28 by 2030 or something like that, because they want to have time we want to have the time to start processing this and then start looking at what this would look like in the field at the plants. We've even talked about running a pilot study and doing some of that kind of work, actually paying the work group to have a plant do a pilot study with some of this stuff to see what that would look like and give us that time to really formalize this.
It'd be nice if you could find a tributary and not the main branch where you could actually see impacts.
And we have a couple plants on trib, so.
Yeah.
But this is, this process and this ranking and this stuff is how the DRCW generated the special conditions list that we have now on our project. So I'm sure you guys are sort of aware, most of you I think are aware of the DRCW special condition. We got a 10-year delay on the 1 milligram per liter to not put into 2025 to work 10 years on these projects that were identified through this process. And the DRCW would very much like to continue on this method and working on these projects and these priority stressors as we move forward.
I think some of the discussion too has like, how do we get, like, if we look at the 0.28, and this for DRCW is, we'd be willing to go down to something lower than what is currently out there, which is 0.5, but maybe it's making a single jump instead of making the steps, because it's potentially cheaper to make that single jump. And then also looking at like this, do we have all of the plants implemented all at the same time? Like, does everybody have the same timeline? Which may or may not make sense depending on where the life cycles are. I mean, if a life cycle of a plant is coming up sooner than others, then maybe they make that jump sooner than others. And so there's a whole lot of discussion going on as to how we look at this number, and then how do you fit that into the 5-year permits? Which pieces go first. So there's a whole lot of discussion going on.
Sorry. As numbers start getting thrown around, I'm just wondering, are we going to have like documentation for everyone just to understand? It doesn't have to be detailed, but not how the numbers were achieved and then how they were validated. Like there's got to be some kind of validation or check just to support the initial product. I think to give credibility to the findings.
Yeah, I mean, we have a final report of this that we have a final report that will detail all the different, I mean, there are like 6 or 7, I mean, I can share you sort of the overview through our WEF white paper that shows all the different statistical analyses that we have. That's sort of the basis of where we are now. But there's going to be a very detailed report on where all these numbers came from. And then there'll be a second report. There's a second report that's our peer review. That's a very detailed analysis of all those methods. And that was done by a guy from Michigan with Kaiser and Associates. He was actually on the NSAT committee before he left his job with the paper mill. He's got a long history of nutrient work, and he did our peer review for us. And so those will all be available in published documents that will be available for you. And then we have different forms of them now, but I can sort of I think the easiest thing that we have available now is sort of that sort of breaks down some of these steps is the white paper we wrote for WEF that I can share with you guys.
Has those steps already been taken before we started seeing these numbers, or I just don't want numbers to get out and they're like, oh, we found a boo-boo in here, we got to change the numbers.
No. The peer review was done way before. I mean, we had those numbers for a while. There were a couple secret people who knew those numbers, and then we were very, like, even Jennifer called me today and was like, can I show them the 0.28? And I'm like, yeah, we've kind of gone enough public with it that we can share it. But yeah, I mean, we know the atmosphere we live in. And like within a day and a half of the NSAC report, I had a meeting with somebody who has a very influential in permits, and they were calling that 0.1 the new water quality standard. So
yeah.
We're very aware of what this means.
Okay.
And you guys recently had a meeting with EAGs and kind of talked through what this number is. So they're aware of it.
Mm-hmm. Yeah, the EAGs are aware of this number. They know it's out there. They're very interested in seeing where it goes. They had some questions, and we're providing a lot of background data and some of these things right now in a forum to Albert to really start to stick his hands into to really get in at. You know we have to go through them, so we work with them.
Yeah. And so, I mean, with the way that this has been put together, I mean, in all reality, this number could be used in probably any tributary stream in northeastern Illinois.
Mm-hmm.
Just 'cause that was the data that it was built off of. And so again, this is just like anything else. It's not a static process. So this is something Stephen had put together, just sort of kind of the whole adaptive management process of continuing to collect data to implementing projects. That's right with DRCW, as they've been implementing projects. They've done a lot of pre-project sampling work and then post-project sampling work for several years afterwards to be able to show that they met the goals that they thought they were going to meet. So with like their Churchill Woods dam removal project, work that they've done up on Springbrook, on Salt Creek, at the Oak Meadows. So there's a lot of data they've been collecting to make sure that the information that that suggested that this type of project would give us this type of result is adequate or is accurate. And so we have definitely seen the fish and bugs improve, in some cases faster than we expected. So those have been really good, but the idea is that we would learn from these projects, and if we were going to implement a similar project somewhere else, we would have information to help guide us, make improvements on that project. And so to
just on the data, I had one more question. Sorry, just these things pop in my head as you're talking.
Absolutely.
So, so we're still collecting data, right? You just talked about doing Hickory Creek this year.
Yeah. So
do we have 2 more years of data that we're collecting?
So Lower Des Plaines, we're just in the first round of this as far as data collection goes. Mm-hmm. And so we collected on the main stem in 18 and 19. Due to weather, we weren't able to collect all the data we needed last year, so we're going to redo some sites on the main stem. We also did the tributaries that are up by O'Hare. And then this year we're focusing on Hickory Creek, and then next year all the remaining tributaries, which are mostly Will County, and then the 2 in DuPage County, Flat Creek and Sawmill. So that'll complete our first round of data collection. And as part of those reports, so we'll get a report for Hickory Creek, and then we'll get a report for the remaining tribs. And those reports will include outputs from the IPS tool. So as part of their report writing task, they will run the data through the ranking part of IPS. So we're not going to be redoing like the stressor ID part of it. We're going to use the benchmarks that were developed through this round of stressor ID. We'll use those benchmarks to then be able to rank and compare to and then rank projects within the in the watershed. So we'll have that list, like we'll essentially end up with
these 2 maps.
Yeah, we'll end up with a map like this, and like Dina said, we can discuss how it is that we want to prioritize the numbers. And depending on how our data comes out, we may have sites that are meeting. And so then we're really looking at it as to how do we make sure we're protecting those sites. But then we'll also have sites that would be more on this side, like where we need to implement projects. And then we'd need to sit down and have this discussion about prioritization. Does this make sense? Because obviously you need land to do a project. And at some point, and this is something we've discussed at DRSCW, all the projects so far they've done in partnership with DuPage County Forest Preserve District, been an awesome partner. There's a lot of value that they bring to the table in being able to oversee the actual construction of the projects. They have a lot of expertise in that. And then the ongoing management down the road, which some of that DRCW is covering funds for, but a lot of that will kind of fold into their ongoing management. Eventually, we're going to run out of sites to do on their property, and those sites are potentially doing sites somewhere down the road are going to be more expensive because we don't have that partner in the forest preserve. And so, it's still going to be down the road before we get there, but we will get there. But having that partner, particularly a public open space partner, definitely makes these projects easier.
And just before we move off of IPS, just because Tim had asked, we are going to be having yet another Zoom webinar, because I know you don't have enough of them. Project committee meeting with Mark from Kaiser & Associates, who's going to go into detail about the peer review. So I'll make sure that Jennifer gets that invite out to you guys if you're interested in sitting in to that call to kind of go over the more details on that.
Lots of statistics. I could have included that slide with the random tree on top of the hill graphic.
My slide that I use, right? So the slide that I use to describe the IPS model is like a sketch of like a bunch of two old men like in front of a chalkboard, and there's like a big like scribble all these like algorithms, and then in one of the steps is a miracle happens, and then there's the output. And that's how I describe the IPS. And then it's got all the examples of the different types of like regression trees and things like that that they have used to do the analysis.
Yeah.
I just call it, I say we put it all in a box and shook it up, and this is what came out.
All right. But yeah, so, after projects are implemented over years, I'm sure at some point, I don't know what the timeline will be, whether it's, another 10 years goes by and we do another round with the IPS tool. There are definitely a whole lot of improvements in some of the statistical capabilities that went into this new round that they were definitely able to do more with. So, obviously those kind of improvements help. So at some point there will be another process to kind of really relook and refine those thresholds. But again, this is really the approach in implementing projects and looking at all the different sources and likely causes of impairments and implementing those management practices, and then collecting more data, and then figuring out, are those stressors still, have we dealt with certain stressors, things that we can deal with, and now have different ones taken their place now that we've kind of moved. If we improved habitat enough, then now we can actually see the expression of some of these other stressors. So that kind of is a long route, covers the IPS tool, and kind of gets at the reasons why we think this really could be a tool or the model to use as the basis of our NARP, and particularly at getting at what that number would be. And like Dina said, using, even with that number being identified, the route that we would take as lower Des Plaines will more than likely, or it could look the same as DRCW, it could look very different as far as what that schedule is, what the projects are, how it gets implemented. But that is sort of the beauty, if you will, of the NARP language, is that it gives everybody show us how you're going to get there, and why, defend that process. But our process is going to look different than another watershed, even if we're using that same target number. So that covers the specifically sort of on that, like the effluent based number approach. But like Dina said, there's other components looking at the non-point source side of things. So I'm going to hand this back to Dina, talk a little bit about where DRCW has been going with some of the non-point source side.
So we've talked a lot within the projects committee and had a consultant webinar, a consultant roundtable to come in and kind of talk about options for non-point source pollution. And we've tossed around the idea of doing another model, like doing a watershed-wide non-point source loading model. You have everything from something easy and simple as a spreadsheet to STEPL to something more complicated as HSPF or another SWIM or some other type of model that includes a water quality component, especially for that land use non-point source side. We still haven't decided what we want to do with that. That'll be a focus that I think we'll have to make the final decision on whether or not we're going to do that this summer. But what we've really invested a lot of our efforts in are targeting in pilot projects, looking at BMPs to help with the non-point source reduction that maybe are somewhat out of the box. We started by funding a study, and I think a lot of you guys have probably seen a lot of the work with Bell Simbring with USGS out of Wisconsin, where he has shown that the main source of dissolved phosphorus from urban runoff is associated with leaf litter, and mainly leaf litter accumulating in the streams during storm events and then being washed into the detention basins and then into the creeks during storm events. And so he's been working on different ways of looking at how to come up with sort of like a best recommended practices for leaf litter. And so we're going to start working this summer with our new employee, following up on some work that DuPage County had done about trying to get good data on what all of our members do for leaf litter collection. How often are they bagged? Are they curbed? Are they thrown in the parkway? We have a couple of municipalities that actually put them in the streets. How all that works. And then maybe coming up with sort of a manual for some BMP, like recommendation practices for them. And then also doing maybe some pilot projects for leaf litter. Obviously the easiest way to get rid of leaf litter is street sweeping. So could we work with the municipality and have them go out and street sweep prior to when we know a storm is coming, prior to a storm, instead of on their regular weekly or bi-weekly schedule, and see what impact we have on reducing that dissolved phosphorus. There's obviously, I assume that there'll be no way to get out of just basic green infrastructure. We're also looking at chloride management. Obviously we have our chloride reduction program, but we do know that chloride and the non-point source inputs of chloride from road salt application are a huge limiter to aquatic life in our streams. We have our existing program, and we're looking at improving on that program and actually we've actually ran a quick pilot study where we looked at how much road salt we could actually get by doing early street sweeping, like after sort of that last storm, if we got the street sweepers out early before the next rain event, how much salt was captured in that with that BMP that you already have. You're just maybe not using it that early, and it had a significant impact. It caught a significant amount of chloride off the streets. And so it just things like that we're looking at, sort of more of those broad things instead of doing a separate modeling effort.
Right. So again, instead of putting money into a model, we're kind of putting money right into pilot projects to determine how we could actually take that information and then implement it. Like you said, come up with guides for communities, or whether it's, like a manual, handbook kind of stuff.
I mean, a lot of research has done that shows in urban areas what those priority pollutants are and where they're coming from. So do we really need another model that sort of does the same thing? Or should we be spending our money on actually implementation, some types of projects?
Yeah. And a lot of this, like with the leaf litter stuff, there's a ton of, all that work was done up in Madison. And the weather in Madison is very similar to the weather here. The way their subdivisions are laid out, all that kind of stuff is very similar. So there's pretty good likelihood that if we took those same practices and implemented them here, we're going to see very similar results. And they've done some really cool education and outreach stuff. And that, maybe definitely a way that Lower Des Plaines could partner with DRCW on some of these things. As you know, we've worked on at least the starts of developing some of these outreach materials. Maybe that's something that we can, you know, broaden our, we're partnering with Lower DuPage, broaden that partnership on some of the education and outreach stuff to make it, you know, across all 3 watersheds. And then based off of information that we get off of some of the pilot projects and things like that that are going on. And I think that was, I mean, I guess the last slide that I had, yeah, it looks like last slide that I had was just the overview of kind of what we are doing this year for the bioassessment, focusing on the Hickory Creek watershed. Some of the work that Dina had started last year with the East Branch, we're doing these expanded dissolved oxygen sites where we would utilize the probes that we have, putting them out for a week, so collecting the continuous DO data, but then in addition to that data, collecting an expanded suite of nutrients, so including dissolved nutrients and the different components of phosphorus. So orthophosphorus, the dissolved phosphorus, total phosphorus. There's a whole list of different nutrients that some of them are beyond what we sample for normally through the bioassessment. And then also doing both systonic chlorophyll A, so the chlorophyll A in the water column, and then benthic chlorophyll A, so scraping it off of the rocks and using that data to look at, have a better understanding of where phosphorus is coming from and how it's reacting in our streams. Does that cover that, Dina? Is there anything to add to that? Okay. And then we have
a very
some
dry and hot season.
Right. And that's work that we'll be doing in the stream. So our new employee, Alex, will be out helping out with a lot of this, and then Dina and I and whoever else we pull into the stream with us to get the work done. And then we also, like I said, we'll be doing some fecal coliform sampling, both on Hickory Creek, and then I've been working with Jen Wasik about identifying a few sites on the Des Plaines to collect some fecal coliform data. So that'll be doing the 5 samples in 30 days to meet the IEPA requirements. And then we'll be resampling a little bit on the main stem. So, you know, continuing the bioassessment program, like I said, we'll finish data collection for the first round next year. We take a year off just to kind of get caught up with the report writing, but the idea is to then continue doing that bioassessment program on into the future. And that definitely will be one of the tasks that we'll have listed in the NARP of continuing the data collection. And then I think what I left it at was sort of next steps, and I might just pull back out of the presentation view and we can kind of go through what some of the next steps would be going forward. I know there's a lot to digest about the information with the IPS tool, and we can, like Dina said, provide some more background information on it so that people just have a stronger feeling for what that can do for us. But then to open it up to discussion and just people's thoughts, and then what we'll plan on doing kind of next steps as far as meetings and input from the group.
Hey, it's Dan.
Yeah, Dan.
As the IPS sort of moving forward as the path for the group here, or are still other options on the table that haven't maybe not been discussed yet?
There are all options are on the table. I mean, it's just, I mean, I think that the tribs, or I mean, it appears that based on where you are going with Hickory Creek, that you at least discussed it at some point to go ahead and do that with the tribs. So that's ongoing, but then that's sort of like the whole point of this discussion was to discuss on whether or not we want it to go, you know, all in with IPS, or do you want to develop another process? Do we want to go out for some sort of RFP, like statement of interest type thing? This is how I would imagine it going, to put out to see if we wanted to hire a consultant to help us maybe break down and talk us through some of those other options that are out there. There's all sorry, my dog is barking. There's all different types of options for modeling out there. I mean, there's, do we want to do a loading based model, like a qual 2KW or model? Do we want to do a more, do we want to do a more dynamic model and look at more like 3D modeling because of the complexities on the main stem? Do we want to go to some specialized model that somebody, I can't even think of off the top of my head, may have, that they've been working on in another similar big river system? I mean, that's sort of where we are. That's what the point of this call was, to sort of throw out, like, here's sort of what we've been working on and what some of the other groups are doing, and what do we want to do? How do we want to move forward with our NARP?
Yeah, and there's a lot of groundwork laid with the IPS tool, and IEPA has seen that multiple times and has liked what they saw. So there's certainly some advantages to using it. I was just wondering, where the group was in the process here.
And if the group, and I sort of threw that out to Jennifer earlier this week, is like, you guys have already sort of bought into it on the tribs. If it could work on the main stem, like with working with Chris on that, is there a need for a second model? Like, why would we need to spend, if we believe in that concept and like those outputs in that path, why do we need to spend money on a second model that may have, what happens if they have conflicting results? Then what do we do?
Right. You mentioned the EAGs have seen the 0.28 or chewing on that a little bit. Has IEPA seen or looking at it?
I mean, how do I say this? I guess I never said this, but when we talked to them, they told us to go talk to the EAGs and to come up with the consensus and then come back to them.
Oh, I totally understand the EAGs are the finish line, but IEPA is the first hurdle. And if they weren't going to like it, yeah.
Yeah, no, we ran it by them. We ran it by them, and they were like, works for us. Go talk to Albert.
Very cool. Yeah, so what would keep another group in Northeastern Illinois from using sort of the benchmark that the RSCW has put together and say, yeah, our streams are just like those, and we've got some data to support that. We're gonna use that.
There is nothing to say that somebody couldn't do that. That's sort of that's sort of just the situation that we are all in, right?
Yeah, right.
These are going to be sort of public notice with your permit application, because your permit's going to be based off the NARP, and therefore the EAGs are going to, when your permit gets noticed and it has some requirements in it of what you're going to keep doing, the first thing that if the EAGs haven't seen it first, they're going to ask to see the documentation that's backing that up, right? So if they're going to be out there, they're going to be public, and somebody may try to, I don't know. I guess technically we own it, but I don't know how much we own it. I don't know how that all works.
Right.
This is Steve. I think one of the things, the arguments that we had some time ago with the DRSCW had to do more with the fact that there's public money being used to generate this data. So we really didn't have control over that once we made it public.
Mm-hmm.
So yeah, we're definitely at that stage where there are other options on the table, but we're also at that point where we need to, it's 2020.
Mm-hmm.
And although we don't have to have a final answer, obviously, in the NARP, we need to have action items and kind of a roadmap. So, and because the tribs are looking, they're just different from the main stem, we could choose to go with IPS for the tribs and be able to really kind of move forward and plan for that. And maybe it doesn't necessarily mean that the main stem has to go the same route. But I think there's definitely, we can look at the work too from MBI, the work they did on the large river stuff in Ohio, and kind of see, what would it take to go down that road. And that was, we actually had some of those we had funds, I think, earmarked in our budget this year to start looking at how the IPS tool could be used for the main stem.
Do you know if MBI has, I know this work did originated in Ohio. Has Ohio EPA adopted those standards that they came out for Ohio? Or did they come up with some standards like this for Ohio?
So the process that they've been working with in Ohio has been mainly with, I always say the wrong C city.
Cincinnati.
Cincinnati, not Cleveland. Sorry. All the cities in Ohio start with the C. Columbus. So with Cincinnati, and they've been helping them. It was mainly started with them. So they did the DRSCW one first, and then they made some modifications working with Cincinnati on their CSO program. They have obviously a lot of CSOs. And they've been working with this model with helping them prioritize and how to deal with some water quality issues through their CSO implementation plan. Now, Ohio's just a very different state. They did not charge Cincinnati Water Reclamation District to come up with a watershed target for their area. They have these various TALU-based standards, and that's what they're using. So, it's just a very different application. Would we have spent as much time and as much, the old IPS did come up with some benchmarks, and we sometimes throw them on a graph, and you've probably seen them on some of our graphs, but we never used them. But now with this NARP process, we're spending a lot more time on those benchmarks than we did before. Before, the whole point of the IPS was looking at the project side of things.
I think also one of the things that we were challenged with at the onset with the DRSCW was that we wanted the TALU, but we couldn't even start that conversation with IEPA or the Illinois Pollution Control Board without some better data. And that's essentially what we've done for the past decade plus.
So we've spent more money and more time on these threshold/benchmarks this round than the other folks have to date, because we knew it was coming and it was a charge that we were going to have to look at. And we also wanted to, for some of our priority pollutants like chlorides, and it really helps us understand what we might need to do. Like that 120 is not a year-round standard. It's not a winter standard. It's more of that spring spawning type standard. And that it kind of gives us a hope to be able to really start to look at and find some internal targets for us to work towards. We're not saying that all these things should become water quality standards by far. We know we know that we don't want that to happen, but it kind of gives us some information and some thought to start thinking about how to prioritize and, do some work.
And there's kind of the wider benefit with the IPS tool is it allows us to look at many of these stressors kind of together instead of looking at everything individually. Because, one of the options with the NARP is to just take the NSAC number. So take the 0.1. But if you still haven't fixed your phosphorus related impairments, well, okay, now what's the next number you got to go to? You're not done. So that's where, I know Dina has answered that question several times in the NARP meetings. Well, isn't it just, why don't we just take the 0.1 and be done? And that's, well, the reason is because you're not done. If you don't fix that problem in the stream, you're still not done. And so this approach allows us to take it's a much more holistic approach to look at the other things. We don't have standards for habitat. So you're never going to see a TMDL on habitat. But if we don't address habitat in some way, we're never going to get beyond where we're at right now with fish and bugs. And so this tool just helps us to look at things much more broadly and then, identify where it is most cost effective to put money, in the stream or in projects up on land. And it's something we're paying for already.
Yeah, the more groups that are using a similar approach with a same or similar tool and are coming up with numbers that are close to each other or maybe the same, that already have some EAG buy-in and IEPA seen the process before. That all just kind of dominoes to something that would be accepted and approved.
All right. So some next steps, we will send out some background information on the IPS tool to help people out. I know there's a few people on who have seen this before, but I know several of you have not. So we'll get some of that background information out. Sorry, I can't really think and type all or talk and type all at once. And Allison, I don't know, maybe this would be something that we could do a general IPS. I mean, we've talked about the IPS model at some of our member meetings, but maybe that's something we could do if we do a Zoom meeting in May. We could get into a little bit more detailed IPS model presentation.
I don't know. I feel like I've seen it a few times, but I don't know if that's because of other meetings or if we've actually talked about it before. I can't remember. I mean, Keith, do you remember going through this before?
I remember talking about it. I don't think we went as in depth as we did today, at least from my memory.
Okay.
I guess my question is, has DRSCW's priorities changed since using the IPS model? Instead of just focusing on the 303D items, have you said, oh, we got to do 100 other things first before we even get to those items?
I mean, Steve Zahner's here too. I don't know if like it's changed because we were never focused on that 303D list. Like it's sort of, you know, when you look at the 303D list, it's so patchworky and it's like so based, you know, it's so specific and so patchworky that's like really is the only issue here. I mean, and it may be in other areas, it, you know, when you look at a stream, it may be true. Like the issue is, you know, metals or something like that, contamination in the sediment. But when we were looking at our streams, so taking the holistic approach, we knew that it wasn't just DO. When you go through our listings, there's like, some of them are related, some of them aren't, some of them are legacy pollutants. But, you know, there's a lot of things that you know about some of the specific pollutants, especially like when you get into the nutrients and the different nutrients, is we might have like a phosphorus impairment or sometimes it will say like, we'll have we have a couple, ammonia is different because that's a toxic, but you have these specific things. And when you look, you know that ammonia, or you know that phosphorus acts different in a functional stream. When you have a Y channel with lots of sun, low levels of phosphorus, that's not moving, you know, that's static, you know, like behind a dam. Lower levels of phosphorus are going to cause algae blooms and growths like that than they would if the stream was functioning properly and had DO cycling with the riffles and the pools and the things like that. So we were never tied to the 303D list as like check boxes. Like that's one of the things that we've never done, is we've never seen that as our end goal. It's just something that's out there that we sort of try. Like for all of our TMDLs that have come out, we have a lot of them in our watershed. We have several DO TMDLs, we have chloride TMDLs, we have fecal TMDLs, we have a copper TMDL. Our approach to implementation in all of them is adaptive management. We want to go after that holistic approach. We don't ever just accept a new nutrient limit and say, that's what we're going to do. We always have an option for adaptive management. And that's how the EPA has allowed us to keep moving forward with a lot of these projects. So even though like on Salt Creek and East Branch, those plants potentially do have low, like very low ammonium and very low BOD limits tied to that TMDL, we've always been able to approach it through that adaptive management. Eventually they may come in, but right now they've been allowed us to keep on this approach.
Yeah, I mean, I could ask Stephen maybe about doing a presentation because he's been the one that's really in the weeds on this more than any of us, but could go through and do a presentation for the group about what the IPS tool, what it does and what it can do for the work that we're looking at trying to accomplish for the May meeting. And we also have, we're at a point now too where there are potentially more of like the screenshots and stuff out of kind of what things will look like with the Power BI that Stephen may be able to pull in and explain better than I was able to. All right. So just trying to think as far as next steps go for this group. You know, I think maybe letting people think about this stuff a little bit, and then we can reconvene and really discuss. Like Dina said, we have the, you know, we have funding in the budget that we could, you know, put a request out as far as having a consultant potentially help us think through some of the other models that are out there, if we think that is a route that we need to go, or do we want to just kind of further investigate as the group is and understand the IPS model and figure out the level of comfort. Because obviously, especially looking at the nutrient number, if 0.28, whether that's actual in-stream or how that translates to a permit, is something that people are comfortable with, is that a route that we, you know, that we're comfortable going with? And like Dina said, going through another model, we may or may not get a number in the same way, or a number that agrees with it, and then kind of what do we do with that information? So we're kind of at this point where we need to, like, what other information do people want? How can Dina and I help provide information to the group so we can think about how we want to take the next steps forward?
Well, I mean, I think, you know, at what point does DRCW's approach get like vetted and approved, and then why would we do something, you know, different? I guess, what's that timeline to understanding?
Well, technically our timelines are the same. Our NARPs are due the exact same day.
Okay.
So we are undergoing permit negotiations right now, because technically we have a 10-year permit that would be renewed at year 5 for the 1 milligram per liter. That would make our first round of plants come online with that one in 2025. So therefore they would have to start construction in the next couple of years, you know, to be ready, you know, start design and construction to be ready to go for 2025. DRSCW has proposed to potentially kick out that one for another time period, with the goal of using that 0.28 in a future. So that we're still working on what that would be, but we would have an answer to that. Well, if the permit doesn't go into a holding period by August, and the first permit's August, but we're negotiating that right now on how that would look. Because we feel it'd be more beneficial for us to do, it'd be financially feasible, better for us to not have this step, to not do 1, then 0.5, then 0.28. That if we could push that 0.28 to a reasonable time, we will continue paying for projects until we get there. So it's not like they do nothing. It's not like we kick that way down the road and we don't spend any money or any investments. We keep working on the IPS projects.
So, because Jennifer, I should know this because I was just doing our permit language, but our permit language currently does not specify a specific model, right?
Nope.
No, it does not. The NARP language is very general. It could, based on what I've been told, you could scribble something on the back of a napkin, and if you feel confident and turn in a 3-page memo, if you could sell that to the IPA, that would work. But you have your challenges, obviously, because your EAGs and your permit reviewers are going to look at that. But they don't specify that you have to do a certain project, certain type of model, or a certain level of effort.
Yeah, the only detail we've got recently is they are expecting a group-wide effort, bring everybody together, including the EAGs, industrial dischargers and MS4s if you can, and do this on a watershed basis. So in a way that's kind of saying you can't just kind of do your own study in a vacuum and expect approval.
Oh,
Yeah, go ahead.
I like the fact that, I mean, at least for our group, we already know that the EPA has approval of the IPS tool. I wouldn't want to probably stray too far from that, just because I don't want to waste a lot of time and money on a model or something else that they're not going to approve of. So I'm on board pretty much with the IPS tool.
Okay.
Yeah, I'm in agreement with that too.
Okay.
So I think it'd be helpful if we could is with, and I think because of the differences is, I mean, if you ask Stephen doing it, when you have bringing in, if we do the May meeting, we should see if we could get Chris to sort of talk about what that might look like for a big river. I mean, I've read a lot of the Cincinnati stuff, but I think it'd be really, I think I would like to have some of that discussion too earlier the better for us.
I mean, I think we've talked about hypothetically for a while now that we could do this, but I think we need some more certainty that this will translate into the big rivers. And I mean, I agree with what you said before, Dina. I think this kind of is headed for me towards like more that tiered aquatic use because I don't know how else it's ever going to make sense. But.
Yeah, I mean, just the main stem within our area is really split in two.
Yeah.
So you have everything upstream of Joliet, or generally where the ship and sanitary comes in, and then everything downstream of that, which is, it's really different.
I mean, it's just even you have those differences and just, you know, we know, I mean, there's enough science out there, not that the DRCW that's doing, you know, Center Water for Protection and WEF and all those that are just showing that with the amount of impervious area we have in some of these areas, we can't get there. Like you know, it's just, and we can't get rid of it. We can't just start, you know, kicking people out. So.
And I don't know if an answer like that and doing a UAA to remove or modify the use is going to satisfy anybody, but you're right.
But I mean, that's eventually we're going to get to a step where either we have to start looking at some sort of either informal, you know, tiered aquatic life use, and the NARP may do that. You know, the NARP may be something that we look at it like that, where we say that our goal is to get everyone to FAIR. Like that might be good. Like, let's stop doing plant upgrades and see what we need to do to get everyone to FAIR. And then we'll work from there once we all get there. I don't know. I mean, I'm just talking like off the cuff, you know, and it's through the NARP and through the permitting process, or do we go and do a UAA and get our own standards, or do we try to get a new tiered aquatic life use standards of, you know, through the pollution control board? There's lots of different options. I think that we might be able to work on some of this stuff, but it's not going to be answered in the next 3 years before this NARP is due, but we can start laying the groundwork and making some recommendations through these NARPs.
One of the other pieces that is a part of the bigger picture as well is how the nutrient trading potentially fits into some of the stuff down the road. And that would be a kind of a whole nother presentation. Mm-hmm.
But we're looking at developing a lot of our nutrient trading based upon the IPS, which therefore would then be something that we could expand to that could be expanded. So. Mm-hmm.
Okay, so we'll get some background information out on the IPS model. I'll talk with Stephen and see if he's available to do the IPS presentation for the May meeting.
Where else could he be?
I don't know. How many other Zoom meetings is he scheduled for? And then I'll also talk with Chris and see if we can't get him in potentially that same meeting and talk about what the Big River stuff has kind of looked like in Ohio and what it would take to take what we have here in Illinois and expand it to the large river end of things. Okay. So maybe we'll kind of let this information sort of settle a little bit, we'll get those presentations up for May meeting, and then we'll see about reconvening again as a group after that. Sound all right for folks?
Yeah, Dina, there could be other groups that are interested in this approach, especially if they hear more groups are taking this approach in a similar tool. Are you ready to take this show on the road?
Are you telling me I should get that patent approved now?
Or are they patent?
Submit patent application. No, I'm just kidding.
Copyrights and.
I mean, I'm talking to other groups right now that still have no clue. They aren't even as far along as your conversation today in lower Des Plaines, you know. So I hope none of them are thinking the permit deadlines are going to stretch out because of the current world events. I don't see that happening. I will mention I was on a call recently that did talking about if you were thinking about extending deadlines because you weren't able to meet recently for obvious reasons and have had delays, you got to get that in writing and into IEPA with an explanation. But there's still no guarantee, especially for a permit requirement that had a 2 or 3 year time frame.
Mm-hmm. Yeah. All right. Well, as you guys think about things, if you have any questions, feel free to contact Dina or I. We'll do our best to answer them, and I'll work on getting presentations pulled together for our member meeting, which is on May 21st, or I'm sorry, May 14th. Mm-hmm. May 14th for Lower Des Plaines.
So with this group, would we plan to meet again, Jennifer, just to stay on track at some defined period?
Yeah, and that's why I think maybe after the May meeting, and those 2 presentations, we could get back together and kind of figure out next steps. Because I mean, one of the steps would be engaging with MBI to figure out what we would need to expand the IPS model for the Big River. Okay. And you know, if that means we need to, well, part of that would be figuring out what data is available out there through Illinois EPA, but then figuring out if we potentially would need to collect any additional data to support that outside of our watershed. And if this is a direction we go, I think it would definitely be good to sit down and have a conversation with Karma and figure out where they're going, because they're tasked to do a NARP, although I think they were going to try to challenge, because I think their NARP was because their risk of eutrophication. And so Dina and I talked with them 6 months ago. I don't know, Dina, when was it? When we took our road trip down to Kankakee.
Like last summer. It was still nice.
Last summer sometime. Yeah. And so they were still trying to figure out, what they were going to do. But if they are going to do the NARP and they're going to be doing data collection, I think it would be really good to talk with them. And if a large river IPS model would be helpful for them in their NARP, there may be some opportunity somewhere to do some level of cost share on that. Or at the very least, not duplicate efforts.
Agreed.
All right. Well, thank you, everybody. Enjoy the rest of your afternoon. Now that it looks like the sun at least is coming out here in Naperville.
Yeah, it's finally getting sunny here.
Mm-hmm. Rivers are all high on my way into the office today.
The East Branch is supposed to be over flood stage tonight.
It was already at 75th Street. It was out of bank.
Was it? Yeah.
Yeah, at Green Valley there.
Mm-hmm. Be about 20 and a half, I think, with flood stage being 20.
All right. Thank you, everybody. Stay safe.
Thanks all.
All right.
Thank you.